And then if you have a, what do you call that? If you put on the bottom, a sticky board, put a little pan on it, stick it down in there, and then when you pull it out, do your hive inspection. You can do your mite count. It's got little squares on it. Who knows what a varroa mite is? There you go. Okay. And then what Varroa destructor. Varroa. It's a mite. It's a little bitty bug, and you'll see it's about the size of a pin, head of a pin. And what they do is they go into the cell of a bee before it's hatched and make sure of the genetics. But one mother gives birth to like 2 or 3, and then they mate. But the whole idea is it's a vector. A varroa mite is a vector, which means that there are certain diseases that it transports. The varroa mite itself attaches to a bee, sucks the living juices out of it. And oxalic acid, like what I use to kill the varroa mites, it will only kill, and at any point you let me know to shut up.
Just keep on going.
Okay, but anyway, the oxalic acid will kill a varroa mite. Oxalic acid is a natural ingredient. You got it in spinach. I make my own oxalic acid sponges, and I put them in my hive. We're not going to tell the federal government that, okay? But you always buy oxalic acid 99.999% pure. And you can find it on Amazon. And then you can find the, what do you call it? The Swedish sponges also. And it's primarily cellulose, so it doesn't form. Starting from the beginning, how many here are allergic to bee stings? Y'all are not allergic to bee stings? We're good, okay? I'm allergic to bee stings, and I take Benadryl over the counter to make sure that I don't have too much of an allergic reaction. Been setting up a hive. Who can tell me what this box is generally called? Brood box. Thank you. Your brood box. And why is it called a brood box? Because it has brood. There you go. Okay? So, and this is called a deep. You'll have 1 or 2 deeps, depending upon the time of year. In the spring, I usually start with 1, and then as the season goes, like I made some newts. They expanded. I've got 3 newts that are doing really good. So I'm at 1, but probably within the next week or 2, I'm going to have to come with another box, a deep. And who can tell me the multiple names that this would go by? Okay, it is a medium. A super, that's another name. What is usually stored in here by the bees? Bingo. You can, and it's optional. What is this called? Say it louder. Bingo, it's a queen excluder. Now, if you're going to be having a queen excluder, this is where your honey's going to sit. So you're going to want to put a queen excluder. And it's not mandatory. What's this called? This is called the thingamajig. It goes on the top. Yeah. Anyway, got a little notch in here where the bees will fly in and out. You can put it either at the front or on the back. And sometimes you can reverse it, whether it's summer or winter. And then this is a lid, and it's telescoping. And then what I usually do is you put the date on the top and what you think. Thank you, ladies and gentlemen.
All right. Good morning. My name is Julie Taylor.
Speaker is recording.
Oh, okay, great. This is new to me. My name is Julie Taylor. I'm an extension agent in Nacogdoches, putting this on. Ricky Thompson is also an extension agent in Nacogdoches. He was outside. He's helping me with this. So thank you for coming. This is the first time we have held a beekeeping course through extension in the county. And everyone here today made it into the course, and I have about 45 people on a wait list. So we will for sure be having additional bee programming in the future. I want to take a minute and thank Constance with the Village NAC for hosting us. Constance, did you want to come up and just say something about what the Village NAC is to introduce it?
Yep. Okay. So Laura's here. She has curly hair. You've seen her. She's running the ropes together. We are co-founders for the Village NAC, and we have created a community here. There's 21 acres for folks who suffer from chronic mental health and homelessness. If someone makes it to our community, they are no longer in a homeless state, and they are now surrounded by community, and we are working together to better people's lives. We're going to be around all day long. If you have any questions about that or what we're doing or volunteer opportunities, we talk all day long. Lots of talking. So we are so grateful that you're here, and we're glad to be a place to host this type of training, and we hope to have all kinds of others as the years go by. So curly hair is Laura, hat is me, Constance. Thank you.
Thanks, Constance. If y'all want to tour anything after as well, after lunch, after the program's ended, they'll be around and they're happy to show you the gardens or the kitchen or some of the homes around here. Yes, and after lunch, I think they're starting a barista up over in the cafe, and so. Okay, thank you for telling me. There'll be espresso drinks for donation, I believe, after lunch in the cafe. Okay, so we have Mr. Garrett here today. He's our extension specialist through AgriLife out of our Overton office. And then the Piney Woods Beekeeping Association has partnered with us. They are local. They're right here in the Lufkin area is where their monthly meetings are. But they're going to be helping educate us today. And if you have any questions, they're right here in our backyard to offer some support. So Rachel Payne is with them. And then we have some other helpers as well. Yes, Edward and Wendy, his wife. And you'll get to interact with them later as we move outside and whatnot. So I'm going to turn it. Oh, sure. Rachel, will you come talk about the Piney Woods Beekeepers? No, it's a recording device.
So it's all on your recording on YouTube afterwards. Go back and watch it. Bet you can't do this.
So I think you have a brochure about our club. There's a lot of information in there. So I'll just add that our meetings each month are free and open to the public. They're family friendly. And we typically have a bee school in the spring that's 3 Saturdays. And if you join our club, then as a member, you also have opportunities to learn how to graft your own queens. Sometimes there are other demos that you would have access to. Now, do note that our June meeting will not be our typical second Thursday of the month, because in June we have our summer picnic. So do not show up at the VFW on the second Thursday of June. But you can check our website and our Facebook page and keep up to date on
on happenings with the club.
Okay, well, good morning, everyone. So welcome to this kind of beekeeping 101 short course. We're excited to have you all here today. So just kind of raise your hands. How many people already have bees? Okay, so quite a few. And then how many people are thinking about getting bees, aren't sure yet, or okay. Well, this is going to give you sort of a short primer on getting started beekeeping. So, one thing you'll learn throughout this course is this is kind of a lifelong learning opportunity. Beekeeping in a lot of ways, it's a managed livestock. So there's a lot that's involved with keeping bees alive. And one thing I'll talk about is just how hard it is to keep bees alive, right? We have to feed them. We have to treat for varroa, other diseases, for example. We have to think about when to add space, swarm management. So there is a lot to do when dealing with bees and beekeeping. So what we're trying to do is give you as many tools as possible, but I do encourage you guys all to join the Pineywood Bee Group, join the Texas Beekeeper Association, which will be in Tyler this fall, and then utilize our resource that we have in Overton. So I always like to do a quick introduction about kind of myself, my background into beekeeping. So I'm originally from Southwest North Dakota. My uncle, he was a commercial beekeeper, and he managed about 10 to 20,000 colonies, and so he shipped bees across the entire country. And you're probably wondering, like, why did I become a commercial beekeeper? One is easier on my back, but number two was these massive bee losses we started experiencing for the past 20 years or so. So for people that kept bees before 2005, beekeeping was really easy. We didn't have as many real issues. Viruses weren't as virulent, right? And losses may have been 10 to 15%. But really, ever since then, it's never been harder to keep bees alive. And so here's a picture of some of my colonies from 2005. I had about 120 colonies at the time, and we lost around 80%, which is really rare at the time. And now, unfortunately, it's become very, very common to lose large amounts of colonies. And the reason I show this to you is even the most experienced beekeepers lose colonies each year. You guys, if you do get bees for the first time, will lose 50%, maybe 100% of your colonies. And that's all to say, just don't get discouraged. Try to find a mentor, try to, figure out what happened and try to make improvements in the future. So I don't want you guys to get colonies for the first time and just say, oh, shoot, I lost all my colonies. Let's just forget about it. So we do have a lot of resources as part of the Texas A&M apiculture team or honeybee team. So this is a pretty brand new program. So the program started around 2024, so a couple years ago. So I had the program in Overton. So we have a research extension center in Overton. We offer a lot of programs in Overton, and I cover the entire state. As part of the program, we have 3 specialists. So we have specialists located in specific areas. So one in Dallas-Fort Worth, one in San Antonio, and we just hired the person in Houston. We're also launching a honeybee diagnostic lab in Overton. That's going to be opening in November. So if you want to submit samples for testing, for example, for genetic testing, if you wanted to see what your genetics of your bees look like, we'll have that all offered in Overton. And we're having a big kind of ribbon cutting ceremony on November 19th for that. So we'd love to have you guys all there to kind of see the facility and see what we're doing. So other programs you might be interested in. So we do a lot of citizen science programs. One is our pollen mapping project. Our goal is to map, pollen that's incoming into the state across the state. And so we're working with around 50 counties so far, but we'd love to work with around 250 per county. So, if you have bees in this area or planning getting bees for this area, feel free to reach out to me or a county agent to get involved with that project. But it's also really cool to see what type of pollen is bringing in and how that pollen varies from month to month. Another thing we're working on, and we'll talk a lot about this, is varroa resistance. So one of our major initiatives is breeding kind of an Aggie line, which is focused on varroa resistance. We'll be launching this probably later this fall, maybe next spring. So we're hoping to kind of sell some of these stocks very, very soon. We're breeding for 2 major traits for mite resistance. Number 1 is VSH, which basically the bees are causing the mite to be sterile. And then 2 is our mite hunting, where the bees find the mites, chew their legs off, and kill them. So we'll have that available pretty soon. Let's just keep on going till. Okay. Sorry about that. Okay, sorry about technical difficulties. Okay, there you go. Okay. This is all. This will be our 16 and B test for bees. So if you're curious what your bees look like, so maybe you want to see if your bees are more Africanized, or you want to see if they're more related to different lines, we'll have this full genetic test available. It's kind of like a 23andMe test but for bees. But also tell you, whether the stocks you're buying are be more row resistant or virus resistant. So like I said, we'll have that fully available by early August. Okay. Finally, we have our master beekeeping program. So our master beekeeping program has 4 different levels, and I encourage any beekeeper to be part of that program. It's really a program suited for brand new beekeepers like yourself, and then even more experienced beekeepers that have been doing for 20 plus years. So our program is really designed for beekeepers of all different skill sets. And so for probably the majority of beekeepers in this room, the apprentice level is the perfect level to start into. So we have a 10-week course as part of that apprentice level. Now the live sessions are over, but everything is recorded, and we basically cover 30 hours of information about getting started. We're also have our ebook as part of our handbook in that course, and it's only $75 to sign up for that course, and you have indefinite access to everything. So if you want more in-depth information on the apprentice or beekeeping, that's a really great course to take. And then you can progress to the program. So for the advanced level, we cover more in-depth information. Master level, we cover, we have different majors, for example, that you can major in. And so it's really a really great course to not only grow into, but really specialized learning based on what you're interested in. So maybe you're more interested in breeding, maybe more interested in, bee plants, for example. We have different courses for you. So really for the apprentice level, the only requirement is to take our 10-week course. So it's a self-paced course. You can take it on your own time. You can take it, within 1 week if you wanted to, or you can take it, throughout the next couple of years or so. But we cover everything from feeding and nutrition, varroa management, disease management, swarm management. So we cover everything you need to know to get started. So and then really, we have written and practical exams to kind of test your knowledge and see whether you retain the information or not. And then one thing I really love about our program, if you do decide to kind of progress through our program, is our master level. So as part of the master level, if you do decide to go through the program, is we have different majors as part of our master level. But these are just kind of our different majors that we have. But it allows you to get more in-depth information on something that you really want to learn more about. So, like I said, maybe that's bee plants, native pollinators. Maybe it's more on diagnostics. And we have a specific course for you depending on your major. Okay. It's on Texas A&M AgLearn. So you guys should have all received a brochure. And so there's 2 brochures, one with the fact sheets. And so the fact sheets are all of our free available fact sheets. And then the other one was about our program. So you go to Texas A&M. What? Yeah. Well, it's kind of a Zoom class, but everything's recorded. Everything's recorded. Yep. So we had our live sessions from February until April. So you can wait until we do the live sessions again, or you can go and sign up now and watch recordings. It's really up to you. Some people like to be there from 9 to 12 to ask questions as we go, but it's up to you. Uh, Finally, before I actually jump into the presentation, is our field watch. So this is a way for applicators, pesticide applicators, to communicate with beekeepers. And so, there's a portal for beekeepers to sign up for free for your apiaries, and there's a portal for the applicators to alert you when they're spraying. So I think it's also part of all of our brochures. So I encourage you guys all to sign up for this program, and hopefully get more applicators to communicate with you when and what they're spraying with. Okay. So now we're gonna jump into the actual presentation. Like I mentioned, everything's gonna be posted on our YouTube channel at TAMUB. So there's gonna be a lot of information over the next couple hours. So I'll send you the link for that, but it'll just allow you to go back and watch the presentations if you want to again. Okay, so we get into kind of biology of a honeybee colony. So we have the hive. The hive is a physical structure where the bees are living. Now, Edward talked about a deep, medium, and all that hive equipment. So us as beekeepers typically manage them in these Langstroth boxes that look just like this. We also have our feral colonies or unmanaged colonies that are living in a tree, for example. But in reality, what's actually inside a tree versus a wooden box are exactly the same. We have the colony or the group of bees. Now, within a colony, we have, and it depends on the time of year, but it can range from about 40,000 bees to 60 to 70,000 bees. And so within a colony, we have our single queen. The queen is the only reproductive and the only egg-laying bee within the colony. And so she can live in a colony for somewhere between 1 to 2 years, and she's really only laying eggs and reproducing within the colony. Now, one thing to keep in mind about the queen is since she's passing her genetics onto basically the majority of bees in the colony, the reason that your colony may be more aggressive, maybe produce less honey or have more diseases is due to the queen. So like any type of livestock, one way to deal with aggressive bees, for example, is by simply replacing the queen with more hygienic stock or more docile stock, for example. Sec- Second, we have the workers. Now, queens and workers are both females, but depending on the food they get during development, the majority will become these workers. Now, workers, they do have ovaries, but they're restricted to not being able to lay eggs. So they're really focused on these non-reproductive tasks. So they do the guarding of the colony. So they're defending the colony. They're nursing the young developing larvae in the colony. They're, basically going out to the colony to collect resources. So they're doing all the hard labor other than reproduction, which is really solely done by the queen. Now we have the middle, which are the males. In the bee community, we call them drones. And the colony only produces maybe 120 drones at a time, and they're only producing the males when there's a lot of food coming in, right? So in East Texas, we have a lot of pollen and nectar forage, early in the spring. And so that's when the colony begins producing the males. Now, if there's a dearth, for example, which means there's a lack of resources, the males get kicked off and killed off. So the male's only role is really to fly out, find a queen, and mate with a queen. Now, every single colony, whether you're managing them, whether they're unmanaged in a tree or whether they're in a lynx colony just like this, the hive configuration for every single colony is exactly the same. So if you look at this, we have the middle, which is the brood. Now you can see the circle. We have that kind of brown spots right in the middle. That's our cap brood. So those are the bees that are going through metamorphosis, kind of like a butterfly that will emerge as an adult bee. On the outside, you see the yellowish, the purplish. That is the pollen or the protein the bees are bringing in. And then on the way outside is the nectar or the honey that the bees are bringing in. So bees tend to kind of build from the inside out. Now, there's one important reason why the bees keep the brood in the middle is to keep it at a specific temperature, right? To keep it from getting too cold or getting too warm. So all the brood is typically going to be in the middle. Now, if you look at this box, and we'll talk more about hive equipment later on, is the bottom brood box, you'll see most of your brood, at least for the first two boxes, and the bees tend to build up. So meaning they put the resources on top and then the brood right in the middle. So, the hive configuration should look exactly kind of like this. Okay, now let's get into queens. So one thing you might have issues with, and I see a lot of issues with at least new beekeepers, is queen issues or queen failure issues, right? So figuring out and diagnosing, do I have a good queen? Do I need to replace a queen? Because once your colony goes queenless and aren't able to raise a brand new queen, that could be a leading cause to some of your deaths. So, we'll talk more about Varroa and viruses later on, but queen failure and queen issues will be number 3. And as a small scale beekeeper, it's extremely more difficult to find a queen, right? You guys don't know how to raise your own queens quite yet, so it's harder to get mated queens if that does go queenless. So we'll go through different signs about what causes queenlessness and signs to help you diagnose queen issues. So we think about why queens are important. There's really 5 major reasons. So number 1 is colony genetics. So if you have any issue with your colony, for example, your colony crashes, has high mite levels, is more aggressive. A lot of that's going to be due to the queen and her genetics because she's laying, 1,000 to 2,000 eggs per day. So, when we think about being a good steward for beekeeping is if you have a really aggressive colony is to simply queen that with more gentle genetics. And you as a beekeeper also don't want to work with really aggressive colonies. Number 2, we have egg laying. So her egg laying is really influenced on what's happening outside the colony. So once the bees start bringing in pollen, and you'll notice the bees foraging with yellowish and purple pollen into and out of the colony, that triggers the queen to start laying more eggs. And so one thing you might see is in the middle of January, for example, the queen's not laying eggs at all. But once you start bringing redbud pollen and pollen in early February, she starts ramping up her egg laying. So her egg laying can range from 0 all the way to 3,000 eggs per day. Then we have her sperm storage. So when the queen flies out on her mating flights, when she's about 5 days old, she'll fly for maybe a week. She'll mate with around 12 to 20 males, and she'll store that sperm within her body to lay fertilized eggs for the next 2 to 4 years. So really, the queen's only leaving the colony when she's really young, or unless they decide to swarm, a year or 2 years later. But what she's doing is she's storing that sperm in her body to lay fertilized eggs for the next, hopefully multiple years. Colony traits and genetics go sort of hand in hand, right? So, you might have desirable traits due to the genetics the queen has. Then finally, we have pheromones. These are, and this is just one way that bees communicate, are through these scents or pheromones. And this can really communicate, I guess, one, is there a healthy, viable queen inside the colony? So one thing you'll see is if you have a brand new queen from a nook, for example, your queen's gonna be really young, producing a really thick pheromone, and the bees will be surrounding her, licking her, and spreading that throughout the colony. But as that queen gets older, that pheromone wears off, and that triggers a colony to queen and replace that queen with a brand new one. Another pheromone is every time a queen lays an egg, she marks that egg with a pheromone, and that tells the bees how much food they need to support that brood development. So the queen's producing a lot of different pheromones that's communicating, everything about the colony and maintaining cohesion within the colony. So this really shows the entire life cycle of a queen. So queen takes 16 days to develop. So, and one thing about bees is they go through this complete metamorphosis like a butterfly. So they have a larval stage, looks like this. They go through metamorphosis and become an adult bee. Now for a queen, this takes around 16 days. Once they emerge, about 5 days post-emergence, they'll fly on these mating flights, and they may mate for 1 day or multiple weeks, depending on how many males are out in the area. But what they'll do is they'll fly in the 3 mile radius, find like an area with 20,000 males flying in the area, known as DCAs. Maybe 20 of them come back to the colony and then proceed to lay eggs for the next, hopefully 2 to 4 years. So all fertilized eggs, so this is one way that bees determine sex, is all fertilized eggs become a future female, so either a queen or a worker, and all unfertilized eggs become male. So that's how the bees in the colony determine the sex. Now, like I said, we have the workers and we have the queen, and they're both a result of a fertilized egg. Now, in most situations, all the fertilized eggs will become future workers, right? If they have a good queen and the queen's doing very well, they had no reason to raise a brand new queen. So they'll be pushed onto this worker trajectory. Now, if you look at this worker trajectory, right, they're raising these small hexagonal cells. In a lot of ways, they receive a lot less food than a queen, as you can see from the top. So the queen's gonna receive about 10 to 20 times more food than a worker. So what happens is, let's say the colony becomes queenless for some reason, so you accidentally crush the queen gets older, or something happens to queen for some sudden reason. They'll raise these really long cells on these hexagonal cells that looks like that, and then feed them a lot more food, and they become future queen. But in most situations, the fertilized eggs will be kind of starved queens in a way. Now, one thing about larvae is, larvae take about 5 days overall, and so once that larva gets to around 3 days old, they're always on the worker trajectory. So the colony has to raise a queen as soon as possible if that queen suddenly dies, because once that larva gets too old, they have some issues. So one thing we recommend is, for example, if your colony goes queenless, for example, and your larvae are too old, you may have to move brood and young eggs and larvae from one colony to the next, so they have something that they can push on that queen trajectory. And so that's why if you are getting into beekeeping, it's always good to have at least 2 to 3 colonies, so you use the other colonies to help out the other colonies. Okay. So this is what the royal jelly looks like. So it's just it's basically a milk that the bees produce. So they produce in their head, regurgitate into the cells, and it basically has all the characteristics of what we consume as milk. Protein, sugars, water, vitamins, everything along those lines. And you can see the larvae are just kind of in that kind of pool of jelly. And then really over the next 5 days or so, they're going to consume at least 75% of that. So they're eating a lot and growing as fast as they can and developing the ovaries. So I don't have this video, so I'm gonna skip that. But if you want to look at the mating behavior, you can go to YouTube and type in, was it here's queen and honeybee wedding flight. But it's kind of a cool video because the queen's flying out of the colony and she flies maybe a mile to 2 miles away from the colony, and there's a bunch of drones that's sitting there. And then once the queen flies into that mating area, you'll see these massive drone comets where they're chasing after the queen, and then a few will latch onto her and mate with her. So this is what it looks like once the queen mate. So if I cut the queen in half, this is what her anatomy would look like. So you can see she has two large ovaries. She has a spermatheca, which is storing the sperm. And so as the eggs are produced and travels down the oviduct, she can decide whether or not to fertilize or not fertilize that egg. So that's really how she's determining the sex of the bees in the colony. And so this would look like if you had dissected an unmated queen. So you can see it looks like a crystal ball, whereas this is a mated queen. So there's about 6 million sperm cells inside that spermatheca that she'll be using for the next multi years to lay a bunch of workers per day. Okay, so how do you diagnose queen issues and queen quality? So this is something I think any new beekeeper should become really really observant of, is figuring out how my queen is doing and whether or not I should replace the queen. Because queen issues is something that I think a lot of new beekeepers will face. The first thing is really understanding the brood pattern. So the brood pattern is basically how solid is that brood pattern. And what I can tell you is, and inform you, is how well the queen is doing. Is she laying a consistent egg laying pattern? Is she, missing many spots, or is she consistently laying in all the spots? And are those larvae and eggs developing fully into an adult? So on the left, this is an example of a really healthy queen, and we'll go into a few colonies and see how they look. What we're looking for is a very solid brood pattern. And one thing you'll see in this picture is there's a few missing spots, but overall, this is a very solid brood pattern. Whereas on the right side, this is actually an example of a failing queen. So this queen is actually running out of sperm, and so she's laying a mixture of fertilized and unfertilized eggs. And one thing you'll notice here, as you zoom in just a little bit, is this an example of a drone cell, where you can kind of see it's kind of popping outside the cell, whereas right next to it, this example of a worker cell. And this would be right in the middle. And one thing, I'm observing right here is that that queen is, laying eggs, and she's trying to lay a fertilized egg to become a future worker, but she's running out of sperm that's leading to a failing queen. And so in this situation, you might want to replace that queen as soon as possible. Let's see the zoom in quick. So that's just one sign. So if I saw this, I might want to do a deeper inspection. Go next one quick. Okay. So next, this example of what the queens would look like on each brood pattern. So on the left side, and once you buy your bees for the first time, this is exactly what the queen should look like. You can see that her wings are fully intact. There's no tattering or bite marks on the wing. She has really a full head of hair, for example. So this is exactly what we want to look like for a queen. Now this example of the failing queen. Now what do you guys notice from this queen? Yeah, so one thing you notice is the wings are basically like bitten off, right? Like half gone, for example, right? And if I took a video of this, one thing I would notice is the workers are actually biting and chewing at her. And I mean, basically the bees are telling you that we don't like that queen. We should try to replace her as soon as possible. And one reason I don't like her is because she's running out of sperm, and eventually the bees will be trying to replace her. So that's the second sign. Next is what we call retinue. So retinue is basically the cohort of bees that surround the queen. So typically there's always a group of 10 to 15 bees that surround the queen. They're licking her, they're grooming her, they're taking care of her. They're also spreading her pheromone throughout the entire colony. So we have boxes that are stacked, 4 boxes high, for example. They're taking that pheromone and spreading to all the workers on top, so they know they have a queen, and they're not going to try to aggressively try to raise a brand new queen. Now on the right side, this example of the failing queen. So one thing you notice is they're just treating the queen as a black plague. They don't like her. They're just not treating her. They're biting at her. So they're basically telling you that we don't like the queen, and we should try to replace that queen as soon as possible. So the final sign, try that, okay, is understanding the type of queen cell. So one thing you'll see is poor brood pattern. 2 is kind of tattering, or at least some bite marks on the wings. 3 is a retinue. And then finally, you can look at the types of queen cells. So really, in general, understanding these type of queen cells will inform you why the colony is raising a new queen. And in most situations, the colony is raising queen for three major reasons. One is an emergency. So this example where maybe you suddenly crush or roll your queen, or she dies for some sudden reason, you'll see what we like to call emergency queen cells. And at time, you'll see somewhere between 5 to 15 of these emergency queen cells. And one thing you notice is it's surrounded by all this nectar. So the bees are just, they know they're queenless. They're trying to raise as many queens as possible because once they get too old, they can never raise a queen again. Now, in the middle, these are known as supersedure cells. They're very similar to emergency queen cells, like they're on the face of the frame, like in the middle. But instead of raising 5 to 15, they're going to raise 2 to 3, and you'll still have that failing queen within the colony. So this is a picture from that failing queen picture I had beforehand, where they're trying to replace that queen with a few of these queen cells. So you'll still see eggs, larvae, and the queen. On the right side, this example of a swarm cell. So swarm cells, instead of being in the middle, they're typically built on the bottom of the frames. And sometimes they're where that plastic meets that wax if the comb isn't fully drawn out with wax. And so when your colony's preparing to swarm, so there's not enough space, for example, they'll start raising a lot of these swarm cells. And in most cases, that old queen's going to fly out and form a new home, for example. Now, you can see these are, for example, these are open. So if you see swarm cells that look like this, or even queen cells that look like this, the queen has probably already emerged and this colony may have already swarmed. Okay. So that's about the queen. Any questions about the queen? Okay. Now we'll get into the workers. So the workers make up about 95 to 99% of the bees. So the majority of the bees in the colony are going to be our workers. Now, one thing about workers is they go through these behavioral changes as they get older. So it's kind of like in a lot of ways compared to humans, right? We have really, young bees are excited about life. They're really nice and docile, and they're doing kind of an inside task, for example. Then once they get older and they've lived through life, they become more mean, more aggressive, and they're the ones that are going outside the colony, coming back and forth. And so you'll see that for sure. And once you go out to the colonies, for example, you'll see the young nurse bees, for example, and they're really easy to hold and take care of. And you'll see the a-hole foragers come in at you and flying at you. So, but one thing you'll see is a worker is going to go through around 10 different tasks and roles as they get older. So when they're really young and maybe 1 to 2 days old, they're doing the housekeeper tasks. So they're cleaning the cells, removing a dead or diseased brood. And if there's any bees with viruses, for example, they kick them out and make sure they don't just reinfect other bees in the colony. Then they become the nurse bees. So they're forming these milk glands in their head to regurgitate that jelly into the cells. And this is not only for the workers, but they do decide future queens. Then they become the construction workers or the cell builders. Have this quick. The construction workers or sorry about that. Okay. The construction workers or the cell builders. So those are the ones that are building, making these wax flicks in their body to mold it into the hexagonal cells. We have the guard bees that are sitting in the front of the colony, guarding the colony. And when something happens, for example, and they're triggered, they produce a pheromone that alerts other bees to fly out and protect the colony. And then we have the foragers. These bees are flying out of the colony and collecting 4 major resources. They're collecting the nectar, which they convert into honey, the pollen, the water to ventilate the colony and keep it cool, and then also resin from trees to clog up any open spots inside the colony. So one way that bees communicate is through a waggle dance. And once you get bees for the very first time, one thing you'll notice is there's usually a part of the colony, frame in the colony that's known as the dance floor. So in the dance floor, you'll see a bunch of bees kind of dancing in a circle, and this is known as a waggle dance. And so that's one way to communicate where these flower sources are. And so this waggle dance is typically done for flower sources, nectar and pollen sources that are about a mile and a half away. What they do is they communicate exactly where that flower source is. So based on the angle of that dance, that tells the bees, which direction that flower source is. Based on how long it is, that tells the bees the distance from the colony. And based on how vigorously they dance or waggle in the middle, that tells them more about the quality of the source, right? So is that a good source or is it a lower quality source? And so the more bees will dance with the bees that are dancing more vigorously or waggling harder in the frame. So one thing about a bee colony is, in a lot of ways they have these individual behaviors, right? So I talked about foraging behavior, nursing behavior, but in a lot of ways they kind of work together as one single unit. So we have to call them sort of a superorganism. And part of being a superorganism is they have these unique social behaviors. And so one social behavior is swarming. Now, one thing I tell all beekeepers is the colony's major goal is to swarm. Like your goal as a beekeeper is to prevent them from swarming, but the goal of the bees is to swarm, right? Because that's one way for them to reproduce and split off and pass their genetics onto a future colony. So your goal, your colony's goal is to swarming, and you're trying to prevent that as much as possible. Now, this is an example of a swarm that recently left a colony and they're forming a temporary home onto a tree branch. But within the next 2 hours or maybe multiple days, this colony will fly out and form a more permanent home. Another thing is a social immunity. So one thing about bees is they're trapped in a box with 60,000 bees, right? And so they're really close to each other, and there's a lot of risk for spreading diseases. And bees have a very low immune system, and one way they combat this diseases and infections, for example, is through hygienic behavior. So, I talked about VSH, for example, and mite hunting, for example, earlier on as part of our breeding program. We're basically breeding for intensive hygienic behavior for bees to deal with it. But this is just one way that bees can deal with these infections. So, this is a hygienic form of behavior where we actually freeze and kill 300 brood cells. We come back 24 hours to see what percentage of the brood cells are removed. And so, if you start seeing a lot of diseases or poor colony health, for example, we always recommend trying to buy stocks that have been selected for some sort of hygienic behavior. Okay. So I'm going to switch to the next presentation about just kind of a year in beekeeping, and then we'll get out into the field and go through some colonies. So it's already set up, so you can come by anytime. Just let me know. But we're setting up a diagnostic lab, so we're getting all the equipment in, and so that's gonna be fully ready by hopefully next month or so. Okay. So next we're gonna talk about kind of bee management and a year in beekeeping. And so after this, we're gonna split up into two different groups. We're gonna talk more specifically about like getting started beekeeping. And so Rachel's gonna discuss, hive equipment, bee suits, difference between a package and a nook, for example. So all that stuff. Really the goal of this presentation is kind of walk you through like kind of a life of a bee and a bee colony throughout the entire year in Texas, right? So you kind of know like, hey, what are your priorities, right now in June versus your priorities in October. So it's kind of a rough kind of overview of everything. But if you have more specific questions about bee equipment, bee suits, and everything, that's gonna be more focused on the next part of the presentation. Okay. So you're in beekeeping, what should you do? So we think about, January all the way to December, there's different things that the colony's going through, right? Like they're growing really fast, different times of year where they're swarming, for example, other times of the year we need to manage viral mites or monitor for them, for example. And so, I'm going to give you kind of a really general overview about, expectations and priorities throughout a year in Texas. So this should all be in your presentation, and I know this might be kind of hard to read. This is part of our Master Beekeeper handbook. So if you take our 10-week course, this will be in the handbook. But if you want me to send that to you, if it's harder to read, just shoot me an email, and it should be in the pamphlet. But what it kind of does, and this is a very general overview, kind of what you should be looking for. For example, purchasing bees, you should be thinking about purchasing bees probably November, December. Right around now, it's probably too late to buy bees. Like there's still people selling them, but this is probably the worst time to buy bees and find people are buying bees. So think about that. Think about, monthly inspections, for example, should be happening from March all the way to October. Think about honey extraction in July and August. So we kind of show you like your major priorities throughout a year. So one thing that's really important for you to understand is kind of the life cycle of a honeybee colony, and this is gonna really inform you of your management steps from one part of the year to the next part of the year. So a honeybee colony goes into really four major stages, from stage 1 to stage 4. I want you to focus on this black line just for now. This is your colony size, and so right around stage 1, which is November, February, your colony is going through overwintering. Now, it's not the same as like the Midwest, for example, but your colony is still getting smaller and preparing for the winter, and your bees will have maybe around 4 to 5,000 bees in November to February. So your colony is really small. Now, once, and especially here in East Texas, we have a lot of natural pollen, and that could and our colonies probably start brooding up maybe mid-January, even sometimes earlier. So it really depends on the type of year. But once that pollen starts coming in, once that nectar starts coming in, your colony starts getting bigger. And so that enters stage number 2, we have your population increase or your colony increase. So they could be doubling, tripling in size within a few months or so. So as the colonies get rapidly bigger, they lose space and they're more likely to swarm, for example, right? That gets us into stage number 3, which is where your colony reaches its highest size. So that can be around, 2 full boxes of bees or 3 full boxes of bees, around 60,000 bees. And so that's going to happen around the next month or so. After that, they start getting smaller and preparing for the winter. So you think about like Labor Day, for example, that's a really good time mark when your colony starts, rapidly getting smaller and preparing for the winter. So understanding these different, size of your colonies will inform you of your next steps. Next is a red line right here, which is your varroa levels. So these are the parasitic mites that are feeding on the bees and transmitting viruses. One thing to keep in mind is that, one, if you're buying bees, you're buying the varroa mites with them. So even if you can't see them, the mites are always there. And two, as your colony gets bigger, your varroa levels get bigger along with it, especially you're not treating or managing the mites. And there's this really important point that every beekeeper might go through if they don't manage their colonies properly. And I call this inflection point in stage 3. And this is typically around, late July, early August, for example. But this is when your colony starts getting smaller, but your mite levels still get bigger, and your mite level starts surpassing the colony levels. And so if you leave your colonies unmanaged and not knock down this trajectory, that's going to lead to a lot of issues later on. And then, pathogens, you see a lot of stress-related pathogens in the spring, for example. I'm not going to go too much into them for now. Okay. So really stage number 1, right? We'll focus on stage number 1, which is your colony dormancy. This is when your colony is going through overwintering. Their colony is very small. And so in a lot of ways, there's not much you can do unless you didn't feed your colonies enough to make it through the winter here in Texas. But in most situations, you should be fine. But really, you think about like November to January, think about, buying your bees, finding beekeepers selling the nooks, maybe find, ones that are selecting for hygienic behavior, get all your hive equipment, get all that figured out before your bees start growing and you start getting your bees probably, February through April. But yeah, think about your hive configuration, for example. Walk through this more in the next presentation. Okay, now stage number 2 and stage number 3, this is where the majority of beekeepers will fail. And this is where you'll have the majority of issues. So making sure to really prioritize your bee management, like right around now, it's gonna be really important for you and really important for your colonies to make it through the entire year. Because in a lot of cases, if you wait until stage 3 or stage 4 for some of these things, it might be too late and you're gonna lose your colonies. And these bees can be $200 to $300 a piece. So we wanna make sure that you're not, losing money by losing bees each year. So hive inspection, we'll go more into this, but understanding how to do a hive inspection. Now, for a new beekeeper, I recommend inspecting your colonies, twice a month to begin with until you feel more comfortable and feel more comfortable with what you're looking at. And I would probably start maybe like early March, for example, if you do have bees. If you get bees for the first time in April, start them as soon as possible. But try to inspect, twice a month to begin with. And try to keep your inspections really brief. You don't have to spend 30 to 40 minutes inside the colony. Now, for your first time, it's going to take you a little bit longer until you feel more comfortable and know exactly what you're looking for. But really have a plan in place when you go into the colony. And so, really, when you do an inspection, you're prioritizing, these major things. First is queen health. So, one are all the things I was mentioning about the queen quality and diagnosing queen issues. But you don't always have to find a queen. If you see eggs, for example, or young larvae, that's indicative that you have a queen and she's doing very well. Second is looking for your varroa levels. So, doing a mite wash, for example, and understanding, are your mite levels high? And if they're too high, for example, you might have to take some action to prevent your bees from crashing from the viruses. Colony health, for example, is your colony healthy? Is it strong? Is it too aggressive, for example? Monitoring those different things. And then finally, a need for space. So does your colony need more boxes to prevent it from swarming? And Even if you have enough space right now and you don't plan on inspecting for the next 2 to 3 weeks, you might want to add space to prevent any type of swarming. And then finally, learn to identify issues. So know what you're looking for when you go into the colonies and learn what a healthy colony looks like versus an unhealthy colony. So this is what it'll look like if you look really closely, right? You see this really young larva, for example. You might be able to see an egg right here. If I saw this, I wouldn't have to worry about finding the queen because it's gonna take you a long time to get a good feel for where the queen is and how to find the queen. It takes a lot of experience. But really, as long as you see eggs, for example, that's a good indicator that you're seeing eggs. Now, if you do have bad eyesight or have issues seeing the eggs or um, the larva, for example, there are these kind of mobile cameras you can take with a screen on it. They're like $20 off Amazon, and you kind of go over the frame to make it easier to find, the eggs and larvae. So there's different things you can use to help you find the eggs and larvae. But as long as you see this, I would be happy to say, hey, my queen's doing well. I'm going to move on. Not all the time. It depends on the foundation. So if you buy, plastic foundation, for example, yeah. But eventually, over time, they're going to put wax beneath it, so it won't be as dark. Yep. But this is actually the easiest stage to see it because once you start seeing the brown, for example, it becomes a lot harder. So really always begin at the entrance. So you tell a lot about the health of the colony by simply standing, 5 feet in front of the colony, seeing if there's any dead bees in the front of the colony, the flight activity, are there bearding or are there a lot of bees in the front entrance, for example. You can tell a lot about the health of the colony by just simply looking at it. Two is always apply smoke and have a smoker available. You never know if the bees are having a bad day or angry, for example. So it's always good to have a smoker just in case. Remove all the boxes if necessary. So when I do my inspections, I'm trying to get down to the bottom 2 brood boxes. So there's bottom 2 deep boxes. And I'm trying to inspect at least 2 frames with capped and uncapped brood. When I look at those 2 frames, you can tell everything about the state of the colony and how healthy it is. Go through the inspection, close it up, make sure you don't roll the queen, and then move on. So we'll cover all this with Edward and I, after the session, but this kind of gives you a brief overview about how to do an inspection. So really, as a beekeeper, you want to be sort of a bee detective. You want to figure out how my colony is doing and is there steps I need to take care of my colony. So the first thing is you're looking for the health and the quality of the queen. So the last presentation, I talked a lot about diagnosing queen issues, but really looking for, are there eggs or is there a queen in the colony? And if so, and there's a good brood pattern, we can move on. But for example, you don't see any eggs or you see, lack of eggs, you start seeing queen cells, for example, you see a very poor brood pattern, that can suggest that you may want to move forward and replace that queen with a new queen, for example. Next is understanding healthy brood. So, you as a brand new beekeeper, you probably have no idea what healthy brood looks like versus unhealthy brood looks like, especially some of these diseases, for example, that you might see going into next year. But the one thing I tell beekeepers is really to understand what healthy brood looks like. Because if something looks unhealthy, you can simply take a picture, send it to our lab or the bee club, for example, and they can help you figure out what's happening. And so this is what your brood should look like. You should see all the different stages of development. You should see them in a clear C shape, and they should be kind of white pearly colored, especially when you put the frames into the sun. But if you start seeing something that looks abnormal like this, where you see scaling at the bottom, they start looking yellowish, you may have no idea what this is, for example, but this looks abnormal, and you can send a picture to the club, for example, or myself to help figure out what's happening. Second is doing your varroa levels monthly. So I recommend at the very least doing it around 3 to 4 times per year, like a mite wash, for example. I do mine every single month, but that's just me. So it's really up to you. Because sometimes your mite levels can spike really fast, and once it becomes too late, they become harder to manage. So that's just kind of what the mite looks like. It's a red mite. If you start seeing mites on the queen, then that means you have really big issues. And then I talked about the queen cells, for example. So one, observing if you have any queen cells, observing if they're open just like this, and observing whether there's a brand new queen in your colony or not. So I talked a lot about this already, but understanding the differences between these will help inform next steps. Edward?
Quick question. When a queen cell is being made, does the queen lay an egg and then the workers build the queen cell around it? Or do they build a queen cell and then the queen puts the egg in?
It depends. Depends on the situation. So, for example, like emergency queen cells, the bees are building the cells around it. For supersedure cells, sometimes they'll actually raise cells and the queen will lay within it. So, in most cases, the workers are just building around it. But you might see like the small queen cups, for example, where you see an egg in it. In that situation, the queen laid an egg and they just built, or the cell was already there and the queen laid in it. Hope that answer your question. Next is understanding a need for space. And so one thing I always say, and this is standard 10 frame equipment. And you look at this left side, for example, you see this is full of bees. So, 1, 2, 3, 4, 5, 6. I mean, really, all the frames are full of bees. Now, if 8 out of 10 frames or 70% of the frames are full of bees, this is going to tell you that you need to add more space, right? And so in this situation, I would add another box to prevent them from swarming. Now, one thing to keep in mind is how long is it going to be until your next inspection? So they may be 70% full, for example, or less than that, but you're not inspecting for the next month. You may want to add space just in case you don't get the chance to see them. Now, if you look on the right side, for example, this is a really small colony, maybe 1 to 2 frames of bees. By adding too much space, that can stress out the bees too much, right? Because the bees have more space to defend from wasps or ants or small hive beetles. They have more space to ventilate. See, there is a risk for adding too much space. So use that scale 80% or 70%. Next is understanding whether feeding is required or not. And so this is the hardest thing to teach to brand new beekeepers is understanding how much sugar I should I feed with, should I feed pollen supplements. Now, you guys are all located in this area, I'd assume. If not, just let me know. But in this area, we have so much natural pollen that you have no need to provide a protein supplement or protein sub. And honestly, it's going to cause more issue with small hive beetles. So at least in this part of Texas, I wouldn't worry about even supplementing with you know protein patties. Now, if you're like west of 35, for example, you might have to add a few protein supplements. Now, the biggest one here is going to be the honey store. So we have a lot of natural pollen, but not as much nectar, right? So you may have to feed more often in the springs, and especially this year, it's been really tough for nectar. I don't know about this area, for example. You guys would know more than I do, but at least in Overton, I've had to feed like 3 to 4 times this spring because there's nothing around. And one thing you'll see is that the bees are actually like going into cells, like almost like they're going into cells to starve and die. And you'll start seeing that more as you get more experience. But really, the thing is, if you see like honey stores like this, like you see frames that have, honey stores just like this, you see nectar in the frames, that's a good sign that, they do have nectar in the colony and that they're doing pretty well. So this is the hive sheet that I use. I'm happy to send this to you afterwards, but always keeping really good records. And I cover this. I cover this as part of our 10-week course. I cover about 2 hours on how to fill this out and what all these different numbers mean. But you can make these inspection sheets in any way possible. But it just allows you to keep track of how large a colony is. Allows you to keep track of any diseases you see, mite levels, and also if your colony crashes, you can go back and look at your records and see, oh, maybe my colony was small, or I had high mite levels, or these different things, and that can help you, make changes in the future. Okay, so understanding the life cycle, right? We have stage 2 and 3. So right now we're in stage 2. So the people that have beekeepers, you're kind of in that kind of growth stage, and then you will be entering stage 3 probably very, very soon, next 3 weeks or so. Now, for stage number 2, you have 3 major priorities. Number 1 is your varroa control and varroa management. Number 2 is your swarm management. And number 3 is your feeding and nutrition. And so just in general, these are just kind of general priorities. There's other things you might have to look for, but these are the major issues you're going to face in the spring. Okay. So when you think about, bee losses, for example, the majority of reasons for your bee losses are going to be the mites, as you can see on the back of this bee, and the virus that they're transmitting. Now, we have ways to treat and control mites, but we don't have a way to treat the viruses, right? So even though the viruses are causing the majority of issues, the only way to control your viruses is by controlling your mite levels. Now, one thing that makes it really hard to control mites is, and we'll talk more about this, is the treatment they're applying. We're trying to apply an insecticide to an insect. So it's really hard to develop really good treatments against the mites. That makes this really hard. Also, the mites like to hide inside the wax cells, so it's harder for the treatment to kill them and harder for the bees to find and kill them, right? So we'll talk about that a little bit more, but varroa is going to be the number one variable you'll have to face as a new beekeeper. So Why should we care about varroa mites? So varroa mites, lower the immune system of bees, transmit deadly viruses, and they can spread really rapidly between your colonies or from your neighbors' colonies to your colonies. So we like to call these mite bombs, where these mites can spread really quickly and cause a lot of issues. So this is a typical life cycle of a varroa mite. At the top, we have our phoretic stage. I like to call this just the dispersal phase. This is where the mites are basically piggybacking on the back of the bee, and they can be spread not only to other bees in the colony, but to your colony right next to it or to a colony that's a mile away. So that's why we call them dispersal or the phoretic mites. Now, these are our foundress mites. So these are the mites that are going to be the kind of this deep red color that are going to begin to reproduce and lay eggs. So what happens is right when that larva is around 5 days old, and they're going to be capped in the next 2 hours. The mites are really smart in that they jump inside the wax cells, and then the workers cap them, 2 hours later. So what that does is, basically the workers are capping them and preventing other bees from finding the mites and preventing your treatments from killing the mites. So they're really good at hiding inside the cells. Once the larvae start, pupating or going through metamorphosis and spinning cocoon, they start feeding on the blood of the bee, essentially. They start laying eggs, about 3 eggs, males and females. Those siblings emerge, they mate with each other, and they repeat the process over again. So the biggest thing for the mites is they're hiding for the majority of their lives. So if you have a lot of brood in your colony, a lot of capped brood, you may do an alcohol wash and you may see 0 mites, for example. But given the next week or so, all those mites are going to emerge from the cells and potentially cause issues later on. And that's why monitoring pretty consistently, like at least every 2 months, is going to be important, because you could have low mite levels 1 month and all of a sudden it spikes to like an uncontrollable level. And as we get into treatments, one thing about some of these treatments is if it gets too warm, if it's above 85 to 99 degrees, for example, these treatments will kill your colonies. So the heat part of it in Texas makes it really difficult to manage. So these are just kind of different colors and shapes of mites. So we have our foundress mites. These are the ones that are kind of piggybacking and jumping to the cells. They lay kind of larvae with the eggs inside of it, and as I would see the males and the females that will mate with each other. So if you actually open the cells and look inside of them, you'll see typically one foundress mite, and you'll see a bunch of baby mites that's reproducing inside the cell. Okay. So varroa management, and I don't have time to talk about everything, but understand the life cycle of the mites. So understanding the stage when they're phoretic, which is easier to kill the mites. That's really where you're killing the mites at the phoretic stage, versus the mites are hiding inside the cells. Understanding when and how to monitor for mites, so understanding thresholds, and then also treating for mites. So, like I said, typically monitoring, once a month, at least 4 times a year if possible. So what I would say is, um, monitor probably beginning in, mid-March. If you can bees for the first time in April or next April, start in April, do it June, August, and then again in October. So at least 4 times throughout the year. And then use 3 mites per 100 bee threshold. And do not rely on visual observations to make your management recommendations. So these are 3 different ways to monitor. Now, if you go to the Honeybee Health Coalition, I don't think I didn't bring the resources, but the Honeybee Health Coalition has videos on how to do all this stuff. You can go to YouTube, you can type it in Google, but they show you videos on how to do both the powdered sugar roll and the alcohol wash. And so this will allow you to, measure how many mites you have in your colony. So powdered sugar roll is you're basically collecting 300 bees. So you get a half cup of bees, and that's pretty much exactly 300 bees. You pour it into a jar. You can make your own jar or buy a device off any bee supply store. You get a tablespoon of sugar poured over the bees. You shake them for a minute. They'll shake the mites off, and then you basically, there's a screen right on top. You just shake it into like a bowl, and you count how many mites you have. And you divide all that number by 3, for example. So let's say you put 300 bees into a cup. You have, 9 mites, for example. You would have 3 mites per 100 bees. So you'd be at or above threshold. Now, the problem with powdered sugar roll is if it's really humid, for example, which it is here in Texas, that sugar tends to clump up. So the accuracy is only 70%. So the most accurate way is to use an alcohol wash or some variation of it. You can buy this device at any bee supply store. It comes with a filter, for example, right? And you see all the mites at the bottom of it. Now you can fill this with 30% alcohol. You can fill this with just straight up windshield wiper fluid, works well, or just some soapy water, and those all work really, really well. we just pour 300 bees into that cup, shake it for a minute, and then count all the mites at the bottom. So I'm not gonna talk about the CO2 method. It's about 20% accurate. The only reason I show it is in case you want to use it. Um, I would recommend it. Yes, they are dead. Yeah, that's okay. So and that kind of is our point, right? So one thing to view about colonies is there's 60,000 bees, right? So it's better to sacrifice 300 bees rather than your entire colony, right? So I view it more as a biopsy. So it is unfortunate you have to sacrifice the bees, but it's better than losing your entire colony, right? And that's one reason that beekeepers prefer the powdered sugar roll is you're not necessarily drowning the bees, for example, but in a lot of ways they become concussed and they die like a week later anyways. And so I recommend regardless to monitor, even if it does kind of start to see the bees drowning into the solution. But really, any sample measuring cup is going to work. Just a half cup, for example, and that's plus or minus 10 bees from 300. So really understanding your IPM pyramid, I'm not going to talk too much into this. We have a full course on how to develop a plan against the varroa mites. But really, we think about IPM, which stands for Integrated Pest Management. So your management against the mites. In a lot of ways, you're prioritizing the biggest part of the pyramids and prioritizing less on the smaller parts. But IPM strategy depends on different parts that you put together into a coherent plan. So number one is trying to find resistant stocks if possible. Two is mechanical methods, so non-chemical controls, and there are organic chemicals our priority over our synthetic chemicals. Okay. So any question on varroa management? I know there's a lot of information on it. I would go to the Honeybee Health Coalition. They have a 40-page document on how to do it, and different treatment strategies, for example. So also take our 10-week course. We cover a lot about varroa management and how to develop a plan. Okay, so next is swarm management. So your colony is going to swarm for really three major reasons. One is overcrowding. So when 70% of your box is full of bees, your colony is more likely to swarm. Two is when they bring an abundance of resources, whether that's pollen or nectar. So, this is typically going to happen in March and April here in East Texas. And then finally, genetics. Some stocks are just more likely to swarm. And you may have some stocks that are swarming 2 to 3 times at a time. So your ultimate goal is to prevent your colony from swarming for really a few different reasons. One is you don't want that colony to swarm and build a home, in your neighbor's shed, for example. And two, you don't want to weaken your established colony because they're swarming. So if your colony gets too big, one thing you can do is simply to split them in half and at least put them in a box you can take care of. So and that's one thing to see with swarm cells, for example. If you start seeing swarm cells, you can make a swarm split and split them in half. So at least they're, going to be into a brand new colony and a brand new box rather than swarming out to some unknown location. So one thing you'll see now, this is a situation if it's too late, you'll see your colony and you'll see a bunch of bees kind of flying above the colony. And maybe some of you have seen this before, but you can type it on YouTube. You'll see a bunch of bees just flying around, and they'll fly probably within 10 to 20 feet from the colony onto a tree, and they'll be clustering on that tree. And what they're doing is they're trying to find a more permanent home. Now, these are the easiest bees to collect. So if you see these, try to collect them. These are just really easy. You can just get a bog-down bucket and knock them in. But within a couple hours to multiple days, they're going to fly off and find more permanent home. Now, what they do is a waggle dance, similar to the foraging, but instead of for food, they do it to find a more permanent home. They come back, convince the rest of the bees to fly to their more permanent home, and they start building their nest and their entire comb. So, one thing I will say about catching swarms or doing cutouts, for example, if you do set up a swarm trap, you can buy swarm traps anywhere. Use pheromones to collect swarm traps. Is you put into a box. What I would typically do is put a queen excluder underneath it so the queen can't fly out and swarm again. Because sometimes you might catch these swarms and they'll fly off and swarm once again. So using a queen excluder is one way to prevent the bees from swarming again. So yeah, one thing about swarm cells. So this is a bad picture because the swarm cells have already opened, so that colony has probably already swarmed or is about to swarm. But if you catch swarm cells like this and your colony is really big, you can simply split that colony in half, and at least that colony is going to raise a new queen with those established swarm cells. So, but one thing you do is you can cut those swarm cells. Now that's temporary, and it might not always prevent swarming, but it's one way to hopefully try to prevent it if you catch it early enough. But really the simplest way to prevent swarming is by adding more space, right? Using that 70% rule. So when 70% of your boxes are full of bees, just add another box or add another few boxes just in case. Now you don't want to do it if it's too weak, but if your colony is large enough, add more space. You can also add, just some checkerboarding, so you can add, empty frame in between full frames to trick the bees. But in general, this is the simplest solution for swarm management. Okay, next is feeding and nutrition. So if you're buying bees for the first time and buying brand new equipment, you're probably starting out with foundation, right? So that plastic foundation that looks just like this. Now, what this plastic foundation is, it has a layer of wax, but has these indents in it, so the bees have something to kind of go off of and build the wax from. And so with this, it takes a lot of sugar and a lot of feeding for the bees to dry out that foundation and build that comb. And so, especially for your first year or first couple of years, and you have a lot of foundation, you might have to feed more often to help the bees dry out that foundation. But you might want to stimulate brood, for example. So if you start seeing a really spotted brood pattern because there's a lack of food, for example, or you see diseases, for example, one thing you do is simply feed your colonies with a 1-to-1 sugar solution, and that should hopefully clear up and improve that brood pattern. And then finally preparing for the winter. So once you get to October, especially if you're pulling off all the honey, you might have to feed the colonies back to put more weight in the colony so they have enough sugar to make it through the winter. So these are really the three major reasons for feeding. So like I said, there's specialized protein patties. Some of them use natural pollen. Some of them are just an artificial food source. But in most situations, I would say here in East Texas, I've never had to feed a protein patty unless there's a certain circumstances. So I wouldn't worry about that at all, since there's so much natural pollen here in East Texas. But you might want to think about a 1-in-1 sucrose solution. And so there's if you actually go to Google, you can type in 1-in-1 sucrose or a sugar calculator. I know the Iowa Bee Farm has one, and Foxhound Bee Company, for example, and it'll tell you the whole recipe and how to make this. But what I would recommend is in the spring, use a 1-in-1 sucrose solution, and then in the fall, around October, use a 2-to-1, a thicker solution to put more weight onto that colony. So is feeding required? So number one, you see a really spotted brood pattern like this. It's not solid, for example. You still see eggs. The queen seems to be doing very well, but overall, maybe the bees are cannibalizing the eggs and larvae. Maybe the queen's not laying eggs because of lack of food, for example. If you see something like this, you may want to go back and start feeding your colonies, especially if they still have a queen. But if you see something like this, for example, a very solid brood pattern, you're going through the colonies, you still see nectar, for example, whether that's capped honey or whether that's inside the cells, this is going to tell you that, hey, my colony is doing very well and I shouldn't have to feed. Because you can get to the situation where you overfeed your colonies and they become what they call honey bound, because you'll feed them and your bees are going to consume that sugar right away and they're going to store it into your colony. Now, if they start storing it where the queen's laying eggs, your colonies can start getting smaller really quickly. So I would say in general, you might have to feed maybe 2 to 3 gallons, probably in the spring, depending on the type of year. So you want to try not to overfeed. So for example, if you see this, for example, on the left side, you see a full frame of capped honey. So maybe you leave that honey in them after instead of extracting it, or your bees are bringing a lot of nectar and capping that honey that looks just like this. That's telling you your bees have some sugar and you don't necessarily need to feed. But if all your frames look just like this, for example, where your frames are empty, you kind of take your box, tilt it up, and it feels like an empty box, you may have to go back and feed them. One thing you'll see is the bees are actually maybe going in the cell, like their butts are sticking out of the cell. That's telling you that they're probably starving and looking for food, like at the bottom of the cells. Like they're kind of like homeless in a way. They're looking for food like in different places. So you'll see the bees is kind of huddling inside them with their butts sticking out. Okay, then finally honey extraction, which is typically July and August. So we started honey extraction probably in mid-July to late July. You wait till August if you wanted to, but one reason that I try to extract early rather than waiting into like late August, early September is there are certain fall flows that can, kind of ruin the taste of your honey. So like goldenrod, for example, snow on the prairie, for example, that can leave a really nasty taste to your honey. So I always try to extract it early on, and then anything they bring in the fall, for example, is this weight they're putting back onto the colony. So I would say in general, the spring honey is the best tasting honey, especially here in East Texas. So I would try to extract probably around early to mid-July. But you don't have to extract if you don't want to. You can keep the weight on the colony, maybe pull a few frames if you wanted to. So it's really up to you. Okay, finally, stage number 4. So really stage number 4, you have these same priorities. You have your viral control, you have your feeding nutrition, and you have your wax moth control. So does look a little blurry there. But same with viral control. One thing about the fall, which is probably October to December, is your queen stops laying eggs, your colony starts going broodless. So all those mites are on the back of the bees. So it's a perfect time to treat the mites and clean them up from going into the next season. 2 is feeding. If you're pulling that honey off the colonies and extracting it, for example, you'll have to feed the colonies more sugar to make it through the winter, especially if there wasn't good fall flow. And then finally, wax moth. These are kind of small moths that will go into your colony once they die and basically, ruin all the comb and build their nest and leave feces behind, for example. So one thing you want to do is if you're storing any old equipment or your colony dies for some sudden reason, you want to make sure you control it because they'll move in really quickly and ruin all the wax in your colony. So as for feeding, we have one full medium, which is a top box right here in this this box. That contains about 30 to 40 pounds of sugar when full. So that's kind of one note here is if you have enough sugar to fill one full medium, then your bee should have enough sugar to make it through the winter. So one thing you'll see a lot about are sugar bricks, for example, feeding through the winter. As long as you're feeding enough in October, you should not have to go to your colonies at all whatsoever in November to January, right? So as long as you have 30 to 40 pounds, you should be perfectly fine. This is what the wax moth looks like. So the wax moth won't kill your colonies. You might see them move in after your colony dies. So they're more of a secondary pest. But once your colony crashes, they get really small, you might start seeing the wax moth burrow into the frames, building the wax and the feces, for example. And so one thing you want to do is either freeze these frames if they die or store them kind of upright so the sun can get in and out of them. If you do see this, the chickens love them. So you take the frames out, go into your chicken coop, and the chickens will love to eat on them. So, okay. So really the most important thing is really understanding the life cycle, right? So, stage number 1, for example, is, thinking about your bees, for example, buying your equipment. Stage 2 and 3 is thinking about swarm management, varroa management, feeding, nutrition. And stage 4 is making sure your colony has enough weight on to make it through the winter. And then also controlling wax moth. So, okay. Any questions on that part before we kind of split up into 2 groups? I didn't talk too much about small hive beetles. They're always going to be in your colonies. They're kind of small black beetles. So as long as your colony's strong, they shouldn't become an issue. Now, the biggest issue I see with them is if I'm extracting honey and leave honey sitting out for a while, they'll come in, they'll ferment all the honey. So the ground, I never do. Yeah, I never had to worry about it. Yeah. You can if you want to. I know there's like salt. You can treat it with like grub exit. The wax moths will still move in. Yeah. Okay. Into the question. I think we'll take a. Do you want to get instructions before we take the break?
Yeah.
'Cause I think we have 2 colors, right?
Take a short break on your agenda. You either have a red dot or a blue dot. So our blue dots, we're going to go outside first.